Tell me when. You good? Okay. Why aren't you going all the way? Dismiss. So. Present. Okie dokie. All right, so now we're past the whole logging in period. That took an incredibly long time, but I already assumed it was going to be like that. So we're now going to go over to the Nix terms. If you haven't already heard them before, such as user. You guys all know what a user is. Typically a human who uses the operating system. User space, the area that a user can play in and play around in. PID, the process ID. A process, so kind of like, probably should have those mixed matched, is a running program. The shell is the user interface. So anytime you're using the terminal or the graphical user interface, you're using a shell. Environment variables are variables that are in the shell that you can edit and manipulate and use. There's a whole bunch of them that's already set up for you to make your life easier, such as the class path. And the kernel is the lowest level software of the OS that interacts between the user space and the actual hardware. So now we're going to go into understanding the Nix commands. So follow the path, and you too will know where the programs live. There needs to be a comma there. So anyone who's logged in right now, I want you guys to type into the terminal. Oh, actually, all Linux users, before we go any further, press Control-Alt-F1, and then log in. What the? Oh, caps lock's on. Wait, why aren't you popping up? Okay. There you go. Okay. Off with the caps lock. Okay. So, if you're already using Linux, go here and kind of just stay here for the duration of the program. Okay. Now I'm going to move back over to the presentation. Okay. So follow the path, and you too will know where the programs live. So type in echo $path. Okay. You guys see what you guys got out?
Echo dollar and then.
Yep, $, then in capitals, path. And everything is case sensitive, so when I write things up here, make sure to keep the case in line. Unlike Windows where things aren't case sensitive. Okay? Anyone see what you guys got? All right. So I'm not going to go too deep into it, but basically, this thing's delimited by colons. Each section that gets split up from split in between the colons is another directory that your command line will search for in search for a program. For example, /bin will be for binary files, /sbin for sub-binary files. They're all binary files, but it's more of just like the more user-oriented files. And then if we go to, now everyone press CD and go into and press CD /. Okay. Yeah, make sure there's a space in between that. Yeah. Good? Everyone good? Okay. Now we're going to move into our first command. So we're now going to go into the structure of the Unix commands. Now there's a whole bunch of stuff here. Don't worry, I'm going to go step by step explaining how this entire thing works. We're going to start off with the commands. So we have our command here. The first thing you ever type into a Linux terminal will be the command. The only other option to use is a Linux environment variable. We're not going to go into that in this tutorial. We'll have that inside the next ones. And this one just happens to mean list. So it means like list all the files that are inside a directory. Probably like the first first command anyone ever runs is typically list to see what directory they're in, see what contents are in there. Everything after the first command are the arguments. And then typically, if you're going from Windows command line over to Linux command line, usually have your commands start off with like a /H or a / question mark or something like that. In Linux, it's almost entirely dashes. So you have a -L and a -T. In this case, for list, if you do if you go list dash L, it'll be dash long. So everyone, type in ls right now, and then type in ls dash long and see the difference.
Username and password is not working for me.
Okay, let me check.
I'm on Linux and I tried to.
Wait, hold on. Is your operating system Linux?
Yeah.
Don't worry about it then. Don't log in.
Because like test it on your own.
Yeah, just test it on your own machine. Yeah. And press Control Alt F1 and log in there. Okay. So yes, so as you probably guys noticed, if we go ls, I get some contents. I got all my files in here, my RuneScape files and all that good stuff. And then if I go -L, I get a big old list of everything that's in there. But I got some other information. This thing right here would be file mode, the amount of files that exist inside a directory. If it's one file that's by itself, then it's just one. Who's the owner, who's the group that it's in, its size, and when it was last modified. And I'll actually go into depth about this part and this part later on. And if you type in -T, it'll actually sort everything by the modification time. So try that out real quick. So -L, -T, you'll actually see that, and compare the dash long to the -T and see how it gets formatted. If you're in root right now, if you have your own Linux system, most likely all the root files got modified at the same exact time since they're all just jumped in there, so there's probably not much of a difference. But if you're in your home directory, you'll probably notice that there's a difference between the modify times. Okay, I'll show you that real quick. So I'm just in my home, -L, -T. It's kind of hard to see. I'll keep it as is. But as you can see, it goes from August 17th all the way up until February 11th. And it doesn't say the year, so that's a bit of a peculiar. But as you can see, the amounts do go in order. So February, December, November, October. Well, actually, no, I'm sorry, opposite. It goes August, September, October, November, December, and then up to February. And it skipped January because I don't think I modified any of these files in January. Okay. Now, this file over here, if you ever put in note 1 or note 2, so let's say you put in the name of a certain file. So for example, I'm just going to go ls-long example. And if you guys noticed, I just kind of went instantly to that. If you were, oh, you guys can't see that. That's not cool. Okay. ls-long, and then ls example. Okay. So if you ever just type in the actual name of a specific file, if you type it in without -long, it'll just reply back that there's a file that exists there. If you get nothing back, like let's say, it'll say ls cannot access that file, there's no such file or directory. If you go back to desktop and then you go, am I still on there? Cool beans. -long, you can actually get the information about that file. So the arguments for this particular, when you put anything else that's not a dash line, like doesn't go dash in a letter, it then takes that as, oh, this must be a file. Now that's not universal to all commands. All commands have different inputs that you might give it. You might give it a string, you might give it a number. So in this case, what this guy takes would be note 1 and note 2. And then this part and this part, I'm going to explain those a bit slowly. So right now I'm looking for note 1 specifically, note 2. Here's where things get a bit weird. So has anyone in here heard of regular expressions? Okay, I'm not going to go into regular expressions today because that'd be a little too much. In Linux commands, you can deploy some regular expressions. For example, you can do the character coding where you want to see either an N or a T, so we can start with an N or a T. The asterisk means 1 or more, as you guys probably remember. If you guys don't know this, then asterisk just means 1 or more in between this. And then it has to find a 3, then have another asterisk, so some other content, and it can have any extension. So something that would fit this pattern would be something like this. tom3.dat. Can everyone see this? Is it too low? Yeah, it might be a little too low. I'm going to raise it up a little bit. I'm probably going to write it over here. Something that would fit would be tom3.dat. The first character starts off with a T. Actually, I probably want to make that lowercase to be specific. Then a whole bunch of other characters, then finds a 3, then a whole bunch of other characters. In this case, there's none. A dot, a period. It needs to have a period, as stated right here. And then for anything else, it just goes on and checks for anything else that's beyond that period. So it's called the wildcard. Be very careful with the wildcard. If you're deploying a whole bunch of commands to a whole bunch of different files and you use the wildcard and you mistyped it out and you end up including some other files you didn't want to include, you could end up destroying everything that you were working on. Okay? So a little bit of regular expressions. And this part I'm just saying kind of, because you can't do everything that you would normally do inside regular expressions. You can't do, if you've seen this before, you can't go, so I can't say get 3 of these. But if you haven't heard of this, don't worry about it. It's not that big a deal. OK. So some commands to try out. So everyone, try these out. I would suggest trying all of them except for exit, because I'll just log you out. So try who am I, try pwd, tty, echo shell, echo path, and then echo insert whatever string you want there. So everyone just play around a little bit, and yeah, see how it works. How long is your thing? Let's see if it can extend long enough. These are all occupied.
Take that table, bring it over here.
That table?
Sit here.
Okay. Yeah, yeah. Okay, so everyone having fun, everyone trying them out? Okay. Also, just a note, if you guys hadn't figured this out, exit will be pretty useful. I didn't go into shutdown, but I don't want, well, no one can actually use shutdown if you're logged into that one, because I didn't allow it to do that. But if you are your own user, don't try to shut down. Don't type in shutdown. Right, shut yourself off. Oh, also, just a cool little thing to show off. When I was first starting off with Linux, my uncle installed Linux on the computer that he forced me to build, and he told me just figure out how to get a graphical user interface on there. And he showed me just a couple of commands, and he said, all right, here's what you got. You got ls, cd, pwd, you know how to log in, and you know where the directories are. So he showed me echo path and explained to me what they meant. So then I would go, okay, well, what's inside of bin? Okay, all right, so I was searching through there, saw some cool things. Then I found something that looked kind of interesting, and I'd seen it before. It was W3M. If anyone does any web development stuff, they probably heard of W3M. And I thought, what could that be? And I was like, okay, to put in a URL. Well, I'll clear this real quick. Let me put in W3M Google. And there we go. There's Google. So if you're ever on just a command line, you need to get online, you have Google at your disposal. So I'm going to look up it's cut off, but on the bottom there's a little text thing that says text, and you're able to type things in. I²C. So now let's plot it there. Use tab to move around. Press enter. I have no idea if the server that I sent you guys on has it, and I think you have to install it. There's also another program called Links. But on Ubuntu, typically W3M was installed back when I was using it.
Hey, it doesn't seem to work for us.
W3M?
I'm installing.
Ah, okay. In which case, don't worry about it. You could also try. Huh?
I want it.
You want it? Are you logged into the SEU website? Oh, okay, okay. Wait, hold on. Are you doing that from your Mac?
Yes.
Oh, okay, yeah, you're not going to have it on there. Because of how bloated up Ubuntu is, and all the other commands that they just shove in there, W3M just happens to be in there. So as you can see here, I'm on Wikipedia, just scrolling about. I can get all the information that I need, an overview. I don't know if I can click on these. Nope. But yeah. Yeah, some cool stuff though. So I'm going to quit out of this, move back over. All right, so is everyone good? We're gonna move on. Okay, so now I'm going to introduce you guys the manual pages. Okay, so the manual pages, so one thing about using Linux is that you're not going to try to remember everything. Don't try to remember all the commands of a specific program or a library. Just remember that there's a thing called man pages. So they're just manuals, such as you can use man touch, man head, man mount, man file system check, man ls, and man echo, and that will give you the manual for each one of these commands. So an example of using a man page would be, if I go into man ls, boom, list directory and contents. It shows you the synopsis on how to actually use it. So ls, the options that you can put in there, and then after that you just put in files. So that's how I knew that the first section should be options, the next section should be files. Then it gives a little description, list information, you guys can read. And then you have all these different commands that you can put in there. And yeah, you also change if you want it to be colorful or not, and so on and so forth. But here's also another really cool thing. The reason why I consider Linux to be a development platform is because the GNU C compiler is already installed on it. And let's say I'm kind of confused on how to use scanf. It also gives you a manual on how to use scanf, the include for it, how to use it, well, what the parameters are, what it does, and if you continue to scroll down, it'll give you more information on it. Sometimes they give you examples, sometimes they don't. It depends on whoever wrote this, and it gets pretty in-depth. And if you're going to search for anything, you can press the / and then go, let's say I'm looking for test, see if there's anything. Okay, that didn't come up. Scanf. Okay. So everything's all highlighted. I can go next. I can press the N button to go next. And then maybe, yep, back up. Did I go to the top? Nope, I went even further down. And then to the top, and I can keep on going. Okay? So those are the man pages. So any command that we've used before, you guys can just kind of do a man page on those and figure out how they actually work. Oh, and if you want to get back to your graphical user interface, it's Control Alt F7 if you guys are trapped. So yes, do not memorize, change your lifestyle. This is a phrase that comes up all the time from Dr. Ozemek. Seriously, don't worry about memorizing these things. Remember a couple of them. Remember where they live. And if you're confused about what one of them does, just do a man page on them.
What is the F7 you're talking about? Just
Huh?
to come out of it, is it? F7?
Yes, Control Alt F7. Okay, so some commands to try out. So you guys can do, here are some more commands you guys can try out. You can do a man page on them. You can actually use them. Another thing that's similar to a man, I don't know if I put it on here. It's called info. Manual used to be like the online manual page, but now it's no longer. And info used to be the text one, but now they kind of just do the same exact thing. So here's some other fun commands you guys can use. Like date just tells you what, wait, that's actually misspelled. Sorry about that, guys. Date just tells you what the date is today. You name, whoa. Okay, I must have not, when I've had the person go over this thing, they must not have figured that out. Uname just tells you what system you're on, so I'll show you guys that real quick. Oh, uname, clear real quick. Linux, well that's very descriptive, I know that. If I go -A, I can then go Linux, the server that I'm using, the kernel version that I'm using, precise Ubuntu, and I don't know if that's the date that I set it up, December 4th. I don't think that's the day I set it up. It might have been the last time I updated the kernel. And then what type of CPU that I'm using. But aside from the first three, that seem to be all messed up. And I'm sorry, the first four, everything else seems to be fine. So ping, if you want to ping some IP address, just choose Google. PWD, print out current directory. History shows you how many commands you typed out. Since everyone's using the same account, everyone's history might be concatenating it to one huge file. What is reap description on a file? Apropos, match commands with keyword in the man page, and so on and so forth. So try them out. And also touch if you use it without a command. I'm sorry, without a argument. So I'm going to go, ls-long random. It was modified last time November 11th. Well, I'm going to modify it right now by doing touch. And if I go into it, it's now February 3rd this time right now. But if you do touch without, with the file not existing, like let's say random2.txt, it'll appear, it'll exist. So you can end up creating files using touch as well.
Hey, how do you get out the ping?
How do you get out of ping? Oh, if you're in a program that gets you stuck, press Control-C. Or maybe Command-C, I'm not too sure on. OK.
And what was that Control Alt F7 you told about?
Oh, Control F7 gets you to the graphical user interface, and then Control F1, 2, 3, 4, 5, 6 are your different terminals. So you have up to 6 terminals that text terminals that you can work on, and then 1 graphical user interface, where the X server spits all the stuff out, which might be a bit outdated because I think X server is moving on its way out. OK. If config does network interfacing, so if you want to see how everything looks on the network, you can do that as well. See if you have an IP address. All right. Do this one real quick. So cal or look a little calendar, little text line calendar, date. If config to see Ethernet, local, Wi-Fi 0, and what my IP address is. So yeah. Huh? Oh, OK. So yeah. Everyone good? Everyone move on? OK, let's move on. All right, now I'm going to go into file mode. So if you notice, after you typed in ls, you had this little extra part right in the front. You're probably thinking, what the heck is that? That doesn't make too much sense. It's a whole bunch of letters put together. Well, that actually splits up into these parts here. So it's 4 segments. And the last 3 segments are the file permissions. And the first segment is the file type. In this case, it's a directory. And for the file types, if it's just a dash, like as you can see in between the R and the X, there's a little dash there. If there's the same dash for the D it means it's just a regular file. If it's an L, it means a symbolic link. A symbolic link is just like a shortcut in Windows, except a little bit more different, but I won't go into that here. A C is a character or device. And then there's the really weird ones, setup ID and set group ID. And then there's sticky. Those ones are a bit particular. S is usually used. I've actually seen S used when you're using programming to elevate permissions, and T also is used when you elevate permissions. I believe ping is sticky, because otherwise, is it not there? Oh, right, ben ping dash long. No, actually, it's set UID. So yeah, it has a little S there, but don't really worry about that today. That's more advanced stuff. The first segment represents what permissions the user has on the file, what permissions the group has on a file, and what permissions the users have on a file. And I think I might have not really spoken enough about this, but there's a concept called groups. So you have all these users that can log into a Linux machine, but you also have specific groups that people can be a part of. And then all users is like, let's say you have a web server and you're trying to let other people get access to that file. This allows anyone to have access to that file. So anyone can read. Oh, actually, I'll go more into detail on this in the next slide. So remember, you guys, just remember that they're OK. I'll do it right here. So the R stands for readable. The W stands for writable. X equals executable. And dash means null or cleared. So here are the ways to modify the file modes. And this one's going to be the text mode. What you do here is use a command called chmod, so change the mode. And you go U for user equals RWX, which means obviously read, write, and execute. Then you go a comma to separate that, G equals RX, and then other people can execute, but they cannot read or write to it. And that's how you set up for the file. You can actually just use U and just set up the U yourself by itself. You don't have to use all 3 of these together. Setting the user, setting the group. And if you want to remove write from all 3, so if you want to remove write from user, group, and everyone else, you can use -W to remove all writes, and you can also do +X to remove to add executability to user, group, and to everyone else. Everyone good? Okay. There's the binary method. The only time octal is useful, I believe the only other time that octal is useful other than using this for file modes is there's a tribe in Mexico that apparently has their base in octal, which doesn't make too much sense because everyone has 10 fingers, and that's the only reason why we use decimal. So take one segment, r-x. If you break it down, that's actually just a binary octal, or I'm sorry, it's just an octal number that gets turned into 5 in octal, and that then breaks down into binary 1, 0, 1, and that the least significant bit is execute, the next bit is write, and the last bit is read. So this is kind of how I figured it out for like the longest time until I found out about the text method. So what you end up doing is, for file permissions, if you wanted to set everything so read, write, and execute, you'd go 7. Just for read and execute, you want to go 5. If you want to do nothing for anyone else, you go 0. And you can go 7, 5, 0 to the file, and now set up its permissions. Okay, everyone good? Any questions? Too fast? Too fast? Oh, okay. Anyone have any questions? Do you have any questions? Okay. So yeah, it's just another way of doing it. You can always just revert back to the text method, which is much easier to remember. But there's also the binary method. Okay. Now here's the last part, which is memorizing. There's usually some tables that you can find online that have like every single combination out there. But as you can see, it probably gets a little bit verbose. But one table that you can keep is this thing here. It has symbolic notation, the octal notation, and what it means in English. So if you go 777, lucky sevens, you'll go read, write, and execute for all 3. So these do the English part for all 3 segments, for user, group, and for other people, for the others, the outside. Okay. And if you guys don't worry about trying to get this thing down, the slides will be online, so you guys can check it out. Okay. All right, now I'm going to go into the super user. No one really has access to the super user because I didn't allow anyone access to the super user. Once you have your own Linux machine, you should be able to do that. Usually there's a command called sudo that allows you to use the super user. Basically what it is, it's a special administrative user. Each Linux machine will have a super user. There's root and then there's your account. It's not like in the Windows where you can have just an admin and that's it. It's capable of system-wide changes. For example, I'm the admin of the website or the server that you guys just logged into. If I wanted to, I could kick all of you guys out right now. And then also set up, like change your files and do a whole bunch of different things on your computer. I can bypass file permissions. Now this one's a bit tricky because there are certain times when the file permissions just say straight up you can't do what you didn't write and say that you could do. But you can also just force read a file that does not have writability from any one of the groups. You could add modules to the kernel. So one cool thing about Linux is the fact that its kernel is modular. So you can add, like, let's say you could take out a Wi-Fi driver, add another driver in, remove another driver, or you could actually add something that's really huge and not have to recompile the entire kernel. So you're allowed to do that when you're super user. Usually the owner of the core OS system. So whenever you go to root, you'll know, or to the root directory, you'll notice that everything there is usually root. Don't ever change that to be anything other than root because then you'll run into a whole bunch of vulnerabilities. Can do almost anything within the realm and rules of the kernel. The super user is bound by the rules of the kernel. You cannot. You can change the inode table, but you have to really go out of your way to do that. And oh crap, I didn't talk about the inode table. I'm not going to talk about it here. That'll be to the next workshop. But if you want to change the internals of a directory file, because all directories and all files are just the same, they're all just files, the kernel will most likely stop you, even if you're super user. Oops, and yep. One other special thing about super user is the fact that whenever you are on a Linux machine, try your best to always use sudo and not use super user, just because of the fact that if you use super user, that session's open and anyone can kind of try to hijack that session. So if you use sudo, there's a kind of a timestamp, and once you exit off the sudo and stop doing that command, no one else has access to admin rights or admin privileges. Okay. Now we're going to introduce file ownership. This one's pretty quick. It's pretty simple. Those two sections here are my name and www data. So I'm the owner of the file. But that file is within the group of the www data group, which means that my Apache server can actually use that file and do whatever it wants to. Desktop is probably like a bad example because that would be silly for people to have that access. But just out of a whim, you have www data as having access to that. So if some girl, Barbara, is part of the www group, she can read and execute from this file. But she can't write to it. But if I change it so that she could write to it, or the group could write to it, then anyone inside that group could write to that file. And to do that, you just have to use chown, cleal, www data, and then file. And it's as simple as that. But if you do not already own the file, you need to be root in order to change someone else's privileges. So let's say Barbara has her own file, and I want to take control over it. Either she needs to relinquish control over it, so she needs to go chown, cleal, www data, or I need to go into root and then take it away from her, but that means I had admin rights in the first place. So a couple of file and directory commands. There's ls, there's touch, there's nano, cat, remove, chown, make directory, cd, word count. There's a couple other really cool utility programs out there. pwd, vim, text editor, and chmod. So if anyone wants to try those out, create a file. You guys are all on the same user, so anyone who's on there, try not to mess up other people's files. You can make a file using touch, using nano. You can edit the file from there. And yeah, so try it out. Try out some of the commands, see if you guys can make. If you guys have any problems or have any questions about any of this commands, just ask me. So I'll give you guys like a couple minutes to do that. Oh my God. It's kind of stuffy in here. I wonder. Huh?
Touch. If I use touch command and try to create a file, it says access denied.
Whoa. Here's what you should do. So if you guys all CD'd into root, do this real quick. Go CD, let me clear this. Whoops. Go CD, money sign, home. CD root. Okay.
So I'm trying the editing command. Now how do I get out of this?
Oh,
I was trying
right here. So it's control exit. I'm sorry, control X. There you go. Press no or yes, depending if you want to save it. Yes.
Getting this. Any idea what that is?
That is information from, wait. Oh, you have Linux on your computer?
Yeah.
Okay, that information is coming from your kernel. It's spewing, That's weird that it'd be doing that. What's the, oh, sorry about that.
It just keeps running, every 5 minutes it keeps running.
Yeah, basically what's happening is, and it's weird because, what operating system do you have?
Windows and Ubuntu.
Okay. Basically what's happening is the kernel is going to send out a message to all the users that are on it. And it's going to spew out, hey, just so you know this is happening. Oh, just so you know this is happening. Typically that only happens when you're actively doing something with the kernel or run a program that has to change the kernel at all. And it's under your permission. I'm not too sure why you're getting that now. And I'm not actually too sure how to disable that because usually my systems, it's usually not enabled like that. But yeah, just try to ignore it for now.
Can I see that slide?
Yeah. Does it work?
No,
Okay.
that worked fine. Then VA is for opening. Okay, I tried it. But what is this echo $path you told, right? CD home is? I'm able to see these things only. What is CD home and what is this path?
Okay. So I'll be going over those and more in the other workshops. But basically, they are environment variables. So what you can do is, check this out.
No, it's something like desktop, Windows desktop. So what is the root directory for us?
Oh, home.
Present, home is the root directory.
Yeah. Well, that's your home directory. Root is the same for everyone.
Okay.
Yeah.
And this path is?
Echo path is your class path, so where all your commands live.
Like C program files / we are printing what is the current drive. Which directory are we in? Something like that?
Drives and partitions don't work that way in Linux.
Okay.
Yeah, so everyone's on the same partition, everyone's on the same drive, everyone has the same class
It
path.
is giving some user / local / bin. But I don't have anything like this here, right?
Oh no, those are, see, if you go ls and you type in one of those and stop at the colon.
If I type ls, I'm only getting these things.
Yeah.
If I give echo path, I'm getting local / bin.
Yeah. So because that's the file that if you go pwd, the current directory that you're in right now is /home/workshop.
Okay, then what is this user/local?
Let's find out. So let's go /user/local/bin. There's nothing really in there. But one that does have a crap ton of stuff in there would be this guy, sbin. You have all these different files in here. So it's going to search in the / or root. That's what that / means. sbin, and it'll search in here to find a program name. So if you typed in any one of these guys, and it goes and searches over here, it says, okay, is it in this one? It'll search every single one of the lines, every single file, and there's, oh, I found it. I'll run this then.
Okay.
But try not to use any of these guys.
I think those two are the.
Let's go path again. Actually, we can go to ls user
38, I think, is the
bin,
Okay.
and there's a whole bunch of different files there. Yes.
So with this one, like what count? Can you tell me what these numbers are? Like 2 to 9. Which one is the like number of?
Do a man page on it.
Okay, command. Okay.
So go man wc.
And I'm trying this Vim and it's
Do vi. Type in vi rather than vim. Vim is the enhanced version. I forgot that.
Which package should I install? It's asking like one of the following.
Oh, the first one. But don't install it. Just go vi.
Okay.
You'll be able to do it. Yeah.
So does it like actually display a file?
It displays the contents of a file. Yep.
I'm trying cat and I get no file.
You get no file? Well, okay, go ls.
Maybe your file was edited.
I don't know what's there.
She didn't have any text in it, maybe?
Oh, actually, go ls-long, so -l. You seem to be able to write to it, or so read from it. So go cat, and then put a capital R, and then press tab. Press enter. There you go. So you must have misspelled it. But if you're typing anything in, and you're in a directory. You start typing away and you get like enough of the word out for it to be unique. At that point, you can press tab and then it'll just insert what you wanted. Yes.
I typed the vim command and I'm unable to exit from that.
Yeah. I said only if you're brave. So let's go escape. Let's go colon, and it's quit. Oh wait, I need to actually Q with an exclamation mark to say force quit. Okay. So one thing about Vim is that it's a text editor, but it has a steep learning curve. So you have to learn how to use it before you actually can use it. So if you'd like to, you could use Nano and edit files that way.
No, if you download Ubuntu, you should have it.
Have what? Vim?
He doesn't have Vim, he doesn't have Nano. He doesn't
You should have VI. Wait, he should have Nano. You have Nano. Yeah.
Cannot come out of the VI. How do I come out?
Okay. Press escape,
Oh, escape,
and then press shift colon. So press colon,
colon.
there's
and then press Q. And actually, do that one more time. So escape
Escape.
and Q with an exclamation mark.
Oh, okay.
Okay. No one try this one. Stay away from that one.
Oh, yeah.
Yeah.
Yeah, it worked. I'm out of it.
Oh, okay.
Hey, what was that one that I learned in my class? The text editor? What is it called? The one that you said was terrible?
Oh, Emacs.
Emacs, yeah. Try that.
Yeah, try out Emacs. I haven't been in Emacs in a long time, so I don't know if I'll be able to get out of it. Don't download GVim. None for Emacs. Oh, you have to install Emacs? Weird. Okay. Don't worry about that one. Move it back. You good, James? I get a Nano? Control X. Damn it, you people, stop doing that. Go to Vim, press escape, colon, Q, exclamation mark, enter.
That doesn't say my changes.
WQ.
I'm using Vim right
No more using Vim. None of that. No more. I'm getting rid of it. Because the thing is, you need to know how to get in and get out And the thing is, yeah, it's very complicated. For example, before, yeah, so you have your insert text editing part, then you have your navigation part, then you have your command entering part, and you have to go escape, then you have to go colon, then you have like all these commands that you can write there. So yeah. All right, everyone good? Everyone good? All right, let's move on. Okay, background and foreground processes. So let's say you're writing a program. Let's say you're using ping. And I'm pretty sure ping will stop when you do this. But if you're using ping and you're like, okay, well, it's going on for a while, but I want to make sure it keeps pinging, you can go Control-Z to put it in the background. And there's a whole bunch of other programs that do the same thing, where there's a program called Top, which will show you all the processes that are running on a computer, on your Linux machine. And if you're like, okay, let me just stop it for a sec so I can do something else, you can go Control-Z. So an example of that would be ping google.com. If I go Control-Z, it'll say that it's stopped, because it stops itself. And I'll go back over to here. So that's how you put it into the background. So now I can do more things. Another way to just, if you know you're going to be putting that command in the background anyway, you want to just do more things, but you want to know that, make sure that command runs anyway, you go command with an ampersand at the end. So automatically just puts it into the background. And then when it quits, it'll tell you. How you resume it? I'll get there. I'll get there. Okay. See how much space is here? Okay, so when you type in jobs is a command. When you type in jobs, you end up seeing the jobs or the background processes. So if I go back over here, I put ping into the background. I'm actually going to put another program into the background. Top, look at all these processes. So real quick, yes. Right now, it's only